Hey guys, what's up? So today we're going to be jumping in and actually creating the circuit diagram. This way I can actually show you guys how we're going to design the circuits on the breadboard and connect it up to the Raspberry Pi. So for starters, we're going to find a breadboard, and we're just going to do a breadboard small. And this kind of represents a physical breadboard, of which we're actually going to end up using. And some of the components that we're going to need, if I can figure out the zoom here. We're going to need a diode. We'll explain what the diode is for, so we'll drag this on the component. We're going to need a resistor. We're going to need a tip 120. We're going to need a motor, which is going to represent our solenoid valve, and then we're going to need our power supplies. And then real quick, let's go ahead and name all of these. So we'll say that this is our Raspberry Pi Pico. And the reason I ended up using a voltage supply instead of an actual Raspberry Pi Pico on here, Tinkercad does not have a Raspberry Pi in their basic components. And then the other one we'll have is our 12-volt power source. And that should be everything we need, actually. So let's go ahead and hook up our 12-volt power source to our positive and our negative. Same thing with our Raspberry Pi Pico. And then let's delineate these. We'll make them the 12-volt red power, 12-volt negative black, so red and black. And then for the Pico, let's make it, since it is going to be a lower voltage, orange and gray. Alright, so the Raspberry Pi is going to be outputting 3.3 volts at, I think the maximum it can actually output is 20 milliamps. Let me double check on that. Pull up our handy dandy Raspberry Pi, 12 milliamps per pin. So we're going to do 0.012 to represent 12 milliamps. And then this voltage is going to be 12 volts, and I think it can output a max current of 3 amps. Alright, so from here, we're going to take our red power supply and hook it up to our solenoid valve. And we'll connect that to our power source. And we've actually got to connect this to a Flyback diode. So essentially what's happening here is we're going to have a current and voltage going to our solenoid valve, which I'll denote quick. And then since the solenoid valve acts as an inductor, we do have to worry about a flyback voltage. That is where this flyback diode is actually going to come in handy and protect our circuit from getting damaged. We'll hook up our negative to the other end. Make that black. We'll take our negative in, put it in with the collector on the tip 120. We'll control that with the Raspberry Pi running the 3.3 voltage source. So let's put that into the base. And then from our emitter, we need to connect that to our resistor right here, and this is a 1000 ohm resistor. And so this is going to be a current limiting resistor. It doesn't do much beyond that. And because we have Kirchhoff's voltage and current laws, we know that we have 3.3 volts coming in through here and exiting through the system. Same with current. All the current that's coming in through this path will be exiting this path, as well as all the voltage and current that's coming into the solenoid valve will be entering the solenoid valve and exiting back to the 12 volt power source. So that is why we have to connect both the emitter to the Raspberry Pi ground as well as the 12 volt power source ground. And speaking of which, we'll go ahead and connect the 12 volt power source ground here. And this is going to be our final diagram. So real quick, we'll go ahead and run our simulation. And just like that, we've got 3.3 volts coming in from the Raspberry Pi Pico. That is powering the tip 120, allowing the tip 120 to act as an electrical switch. And the electrical switch allows the 12 volts to actually power on the solenoid valve. Similarly, if we decide we want to turn off the solenoid valve, which will be the main state, all we got to do is turn off the power to the pin to the Raspberry Pi Pico, and that stops all voltage to the solenoid valve. And that's it. It's a very simple circuit and diagram, and this should be very quick and easy to set up and get running. If you guys haven't had a chance to already, make sure you subscribe to the channel. We really appreciate your support, and we look forward to you guys watching the next video. All right, take care.